So weird. It is like one of the weirdest switchers I think I've ever used.
Right. So, and you know, I went live while you were doing that, right?
Yeah, I noticed that. You love doing that, don't you?
I do. It was T-minus 17 or something like that. Hold on, here we go, said Landfill. So hello everybody.
Hang on a sec, I got YouTube noise. There we go. That's better.
YouTube noise.
Yeah, so I was checking out the chat to see who was in it and trying to respond and see how StreamYard was behaving versus YouTube. And so when we started going live, about a minute later, then I start getting our audio feeding back into my headphones here. So I was like, what's going on?
Right. Hey, do that June to infinity thing again.
June to infinity thing? You mean like this?
You had the picture-in-picture. Yeah. There's your snapshot, your thumbnail.
Yeah, there you go.
That's funny. Do you remember Adrian talking about in his backyard taking the shot for the thumbnail and having the neighbor going, "What you doing, buddy?"
Oh yeah, it was.
It came out, and you could go, "Oh yeah, I could see the neighbor wondering what he was doing for that video."
So apparently we're having trouble with your channel, Bill. Your channel didn't start streaming.
Why?
It is a good question.
I am watching my channel on. It's working. Kevin says it's working.
Okay. Well, if Kevin's saying it's working, then yeah.
And Chris says he's watching Bill's channel. Okay.
So I would say Mr. Landfill reload Bill's channel.
Yeah. But
yeah, there you go.
But you guys tell us. Now, remember Heisenberg, though. You can change the measurement of the video channel by observing it. So
that's right.
Be careful when you observe our channel, you'll knock us off the air. So that's why I don't monetize. So what were we talking about right before I punched that live button?
Good grief. I think we were talking about Coral. We were also talking about 3D printers. We were talking about other things. Where should we start? Coral.
What'd you have to do with Coral? Anything?
What did I have to do with Coral? Well, I was one of the crazy people that decided to make an operating system for this crazy board. Which I happen to have right here.
Yeah, it is kind of crazy, isn't it?
It is crazy. It's a completely nutso board. So we had been building kits for a project called AIY. And this was our latest thing that we were doing for Coral, which essentially was the same team. We just branded ourselves as Coral. And you can see, like, it's kind of a weird design. If I take it out of its case, which was so awesomely designed by Matthew. Yes, that Matthew Wilson, who's talking in the channel right there. Yeah, exactly. You can see it's actually made of two parts. So we've got the SOM up on the top, and then we have the baseboard. And in AIY, we were building things for the Raspberry Pi. And so we got it in our heads that we should design this thing to follow the same model. Yes, you, Matthew. And so this is actually a Raspberry Pi compatible GPIO header. And then we went with the USB-C connectors, a headphone port, Ethernet, and standard USB. But yeah, like the whole project was geared up to run Linux and be as open source as we could. So the CPU on this guy is actually an IMX 8MQ, which is about as open source of an SoC as you can get. So what this runs in terms of an operating system is a derivative of Debian Linux. Now, unfortunately, we couldn't use the name Debian.
I didn't know that.
I mean, it's actually, I don't know if it's trademarked or not, but like we shouldn't have really used the name Debian because we were actually modifying the operating system significantly enough and duplicating the upstream repositories that we didn't want to confuse people because this wasn't going to be straight up Debian. except it really
plus
kind
your
of was.
Google too. You do it
Right.
your way, right?
Right. And so, yeah, I ended up taking Debian Linux, and we made a few extra packages to layer on top so that we could support things like the IMX8MQ, the HDMI out, the audio, and then also the other chip on this board that nobody really talks about right now, but they probably should because it's what makes this board.
Right.
The Edge TPU, which is
Right.
sitting underneath this gigantic heatsink.
Right.
So.
Right.
There's a few stories about how this thing was built.
Well, let me ask real quick. There's a TPU, and the Linux operating system is there to queue up and feed information into the TPU and take it back out and
Pretty much.
structure it for whatever wanted to know what the information was, I assume.
Yeah, so you would essentially take your existing model, say like Inception or some kind of AI model that you want to do inference with, and you would load it up onto the Edge TPU by way of Google's libraries, which would just push the model out into the TPU and then tell the TPU, go run this thing.
Okay.
And then it would interrupt the SoC, and then you'd get your results back. Usually through like some memory interface. I forget which one it is. I think it might be PCI, not entirely sure. Actually, yes, I do know. It's
that
PCIe.
would make sense, yeah.
Yeah. But yeah, I mean, we made some choices with this thing because the massive heat sink, I mean, this is clearly not what a Raspberry Pi does, right? Like if you look
Right.
at a Raspberry Pi, they don't have a giant massive heat sink. And
Well-
part of the reason we had to do that is because of the SOM that we chose. It's just a really power hungry SOM, or sorry, SoC. But also the Edge TPU itself
Right.
is a gigantic power hog. So during the bring up and development of this board, we were really concerned about like the surface temperature of everything, of all the components and stuff.
Right,
like
right.
we had to be under a certain amount, even though it's a developer board. We don't want to burn people's skin, right?
Oh yeah, if you're going over 85 at a prototype, you've got an issue.
Exactly. So we had to find a way to reduce the heat output of this thing, and at the last minute, we didn't have a good way of trying to reduce the leakage current from the SoC. So
Right.
the SoC was just pumping out wattage like crazy, but we could control the Edge TPU. And so I ended up writing a Linux driver to yank the TPU off of PCIe and then shut down the PMIC that was
Okay,
controlling the Edge
okay.
TPU. And I think we went down like a good 4 watts when you're not
Watt?
using it.
Didn't you
So
have a
suddenly you're
problem
okay.
with a floating I/O line too?
Not on this board. That was actually on glass.
Ah, okay.
Yeah.
Okay.
So funny story about that one. We used a TI OMAP 4, and we followed the datasheet. We actually put the chip on the board correctly. We used their layout instructions and everything, and they said, "Hey, let's just like do everything right. You put some of these pins, you don't give them connections. They're like no connection here and there, and
Right.
that kind of thing." And then all of a sudden, we started having these issues, like right towards the end of our, I believe it was the PVT run. So inside of Silicon Valley companies, you do your early prototypes, and then you have your engineering validation test, which is just to make sure that the circuits work. Then you
Right.
have DVT, which is your design validation test, and that's actually talking about the mechanicals.
Okay.
And then you have your PVT, which is it's like pre-validation.
Pre-production.
I don't know what production validation test. Yes. So
Okay.
that tests your production manufacturing line. And
Right.
so at that point, all of your circuits are supposed to be done, right? The trick was we got to PVT, and nobody could figure out why. We were crashing our SoC. We were crashing the
Right,
OMAP 4
right.
hard. Like it would crash out so bad that it started just spewing out heat. And so obviously, being up here, you end up with some really crispy bacon. So we had to figure this out. And the end result was in a mad dash, we figured out what was going on, and we found out that TI's own data sheets were wrong. The actual solution was all of those no connect pins that we had previously not
Right.
connected and just left floating. We had to ground them. The minute we did that, it started working.
Right. Do you think they were doing something as stupid as oscillating, or was it something more complex like, oh, hey, time to do an interrupt?
It's probably oscillations is my guess.
Yeah.
So we had enough, like the density of the board, like you're talking maybe like a centimeter and a half of height, and then you had like maybe half a centimeter of depth, and the board itself was so crammed full of equipment that we had, I think it was like a 17 layer board or something like that. It was some crazy number. So we had traces going on top of traces. Like it was just one of those crazy, super, yeah, exactly. Super crazy design. It was not HDI, which is what we should have done. And the end result was that just we had tons of noise all over the board. And so having floating pins like that probably was the death of the board, is my guess.
Yeah. Now, in my day, we called the runs, we did alpha, beta, pre-production. Actually, there was pre-production and pre-production, and then we were throwing a grenade. There wasn't much else after that. We would go to production and then do design revisions. But that was on, we're already selling the units.
IMX8MQ. This is actually the same SoC that is inside of the Librem phone, like the free phone that came out a while ago. It was like it's like a $700 phone that's made full open source from top to bottom. They also have a heat problem because they're using that stupid SoC.
Well, there's your problem.
Yeah.
Oh.
So for a while, I was actually collaborating with them to try and figure out what we could do about that, but neither one of us came up with a good solution.
Right. So, but you got it done. It stopped being hot. That must have felt good. I mean, I know what it's like to sit there and go, it's going to be hot. It's not hot. No, it's hot. Not hot. You're in denial, and then it's like, wow, maybe it's fixed. So yeah, I made an egg cooker out of a switch mode power supply not too long ago.
It was at a Hackaday post or something.
No, it was actually something I was working on. The bottom line was I had tried to use one of the newer coils, and it's like, ooh, new compact coil. It starts to get warm. It starts to give up the ghost. It literally is the definition of runaway. The hotter it got, the hotter it got, the hotter it got, wow. And the inductance is going to crap. The capacitors on the output were going to crap. So, yeah, I put a big coil and doubled the capacitors on the output. All good.
Cool.
Yeah.
And that's analog magic to me. That's something I'm still trying to figure out.
Yeah. It's, didn't you used to watch a creek or something? You said when you were young,
a creek.
So we were talking about water flows, and that's, I think, where I learned something about computer flow was playing in a creek and watching the way turbulence flow and eddy off, because eddies are a real thing in what we do.
That's what I heard from some of my double E friends.
Yeah,
including you just now.
Well, we thought in the old days that when we gridded the grounds, we thought we were breaking up eddies. And
interesting. Huh.
I don't think that turned out to be true.
So that's actually really interesting. I've been wondering about that, because there's a lot of deck boards that I have that use crosshatch patterns for the copper fill. And I've always wondered if that was because they were like trying to reduce stress on the board, or if they were trying to figure out something else.
Part of it is manufacturing, I believe, and it's just to balance so it's not just huge sheets of copper back then, versus a blank part of the board would get over etched.
Right.
So, but yeah, the whole thing, acid in the corners, been there, done that. It's not a problem anymore. So back to the coral. How long did you guys have to do this thing?
Oh gosh, I think Oh, I want to say maybe a year. We
Okay.
had a fair amount of time to get there. So before this board, we brought up another set of internal boards.
Right.
So we were a rapid prototyping team inside of Google Research, and
Okay.
the whole point of our existence was to actually build hardware for the AI
Quickly.
researchers, so that they
Right.
can have something to test their theories and their designs and stuff on. And
That sounds fun.
it was a lot of fun back then. It really was. Not so much now, but it was definitely a lot of fun then. And
That sounds fun
this
back then.
board, we had several teams that were trying to use this board as the brains behind some of their projects.
Right.
And I think we even had, we had a lot of real early precursor things to things that are coming out now that were built on that board.
Right. Right. Oh, that must have been cool.
It really was. It was a lot of fun. So
and we were talking. Go ahead.
No, go ahead.
Well, I was going to say we were talking before the show that I commented on. You have two edges with connectors, and then unfortunately a third connector on one side, just which isn't bad, but it in the old days we used to try and not reference both sides of the case because the tolerances would add up.
Right.
And the other one was for the board holding capabilities. Sometimes you needed the fingers to grab room.
So Matthew found a really neat way to solve that problem with this design of this case. Well, so it's got this outer ring, and it sort of grabs on. And so the end result is that the tolerances aren't too bad. Yeah. And aside from my clumsy fingers getting this thing on, once it's on there, you can see like it actually fits really well.
Right.
Because of that gap up on the top.
Right.
And all the connectors fit with a fair amount of tolerance in there. Like they do slide around a little, but not a whole lot. And incidentally, Matthew and I both, Matthew and I both were arguing with our board layout people to try and get all the connections all on one side. And in the end, we couldn't actually do it on this board. We ended up doing it on a later board, but because we were trying to imitate the Raspberry Pi, we had to kind of follow their layout of connectors. So yeah, Matthew has views on connector placement. I have views on connector placement.
Why were you trying to follow the Raspberry Pi guidelines?
Well, we had a lot of people that were doing AI research using some other boards that used similar layouts to this. Sort of in the embedded space, the Raspberry Pi is kind of like the thing you need to imitate because that's what everybody prototypes with.
The footprint? Does that trigger people to, I can stack it with a Pi or something?
Well, yeah, I mean, essentially it's because of where the connectors are, people end up building mechanical enclosures around where those connections are placed.
Right.
And so between the layout of that and then also this stupid, and I do mean stupid, GPIO header. Like electrical signals being in a certain layout on this header too. Like that makes it easier for people to just drop in one of our boards in their project.
Got it.
So that was kind of the aim there. And we ended up ignoring that later.
Right. So, and what is a TPU?
So the TPU is Google's tensor processing unit. It's specific to TensorFlow. So you would actually build your models using TensorFlow and then run them on this TPU. It's essentially a coprocessor that handles running an AI model in a more efficient way than, say, the CPU would, because it has hardware that's specifically designed for it, including like the multiply add structures that you would need to do cascade. Make the math easier than you would normally do with just a scalar like ALU that's on a standard CPU.
Does it emulate neurons?
Well, in theory, the math does. I don't know enough about it to be able to say yes or no.
I got you. I've seen that I don't
Yeah,
want to
so
say that equation, but that
so
concept.
so every node inside of a model
Right.
has they have an activation function, which is supposed to be kind of modeled around the way a neuron works, because like a
Right.
certain voltage potential and then you're on, and then a certain voltage potential and then you're off. And so inside of a model, you have kind of the same structure. It's not exactly the same as like what's actually in your head,
Right.
but it's close enough to get kind of like the same
So it
general
kind of
behavior.
distills down and has feedback.
Yes, and in some cases, yes.
Okay.
It
All
depends on the
right.
type of model. So if you're talking about your typical convolutional model called a CNN, those are usually just like back to forward. It's a linear path.
Okay.
But if you're talking about other ones like LSTMs and then some of the newer ones, they have feedback paths that go back into the beginning so that you have essentially memory that you can use for a short period of time. So
Right.
if you've ever played with like Bard or better would be Chat GPT, and you send it a bunch of messages and stuff, over
Right.
time it starts to loses the ability to track the conversation, and that's because
Ah.
we can't give it an infinite time to back propagate all that stuff back to the front and stuff. It's way over my head in a lot of this stuff.
No,
So
you're
I mean,
doing
I
a
may
pretty
be
good
totally
job
saying this wrong.
describing it. So cool. Very cool. Yeah, I got and played with mine. I wasn't going to sit there and train it how to do cards, but I would watch a YouTube video on it doing the
Mhm.
cards, so I was good with that. So
Awesome.
and having one to hold, that's cool.
Yeah, that's exactly what we built it for. Like it's exactly what you say. Even like we did when we built this thing, we didn't know what our users were going to do. We really had no clue, and
Right.
we
Okay.
were hoping that people would come up with really awesome ways to use this thing. And the long and the short of it is, some of them did. They did some pretty cool stuff.
Right. And now you said that in past tense. It sounded like, is this still running
So
production?
I say it in past tense because I have not been in the Coral business in a while.
Okay.
So my team ended up going and working on other researchy things. So today I'm actually building operating systems for running models in a secure way, and it's actually all open source. And I
Okay.
say that the word secure kind of like with a careful nod towards what security is. So security is a process; it's not a state.
Right.
But the system that we're using is based on SEL4 and Rust. So it is actually mathematically proven to be secure in the base level operating system of SEL4. So
Mathematic.
essentially, sorry, go
Hmm.
ahead.
I've not heard the phrase mathematically proven to be secure. Is that
Ah,
a risk assessment um
so,
statistic?
well, not really. So this is actually more like logical proofs. So if you've ever used a logic solver like Isabelle,
Right. So unlimited state machine testing on all the stimulus
yes,
and deriving it down,
exactly.
including
So
time. So it has states. Yeah.
it is not hacker proof because you still have certain constraints there, right? You have to make an assumption based upon certain things that you are willing to accept. So, like SEL4 will not protect you against side channel attacks. If someone decides to go in there and start doing rowhammer on your machine, there's nothing SEL4 can do to help you. There's nothing my software can do to help you. Spectre, Meltdown, you're done. Like those are kinds of things that we have to just accept as being unsolvable for the short term.
Right.
But it does have proofs based upon a set security model. So like SEL4, after still have pliers and rubber hose. Exactly, Charles. Exactly. Good to see you too, Charles. I haven't seen you and haven't heard from you in a while. That's awesome. So Charles and I actually started. Well, I don't know. I don't remember offhand when Charles started, but when I first started at Google, Charles and I were in sysops together, and
Okay.
we were just like doing all kinds of crazy stuff inside there. We actually maintained all of Google's corporate infrastructure.
That's too cool. I
Yeah.
was I was going to start introducing you as used to know the root password for Google.
At one point, we actually did where we had somebody had printed up shirts that said, "I have root at Google." That has not been true for years at this point. So we went through like this crazy we went through this crazy period where we went totally nuts on trying to make everything secure as a process. So
Right.
we do a lot of things to make sure that people do not have root at Google. So
Right. Right.
all your data is safe. In other words.
Or and as I asked one time, is even the concept of root going away? Is it does it all distill down to one origin of authority, or is it layers of API and stuff?
Oh no!
What's laughing at?
CDI, are you Mark Merlin? I gotta know, because that would just blow my mind. So there's a whole cadre of people at Google that I started with in sysops,
Right.
and like we all kind of have like this real strong bond between each other. Okay, so it's not you, CDI. Gotcha. But Mark Merlin was also one of the sysadmins at Google. Brilliant man, and one of the best people I've ever worked with. So,
Oh, cool.
a lot of good feels there.
Yeah. Oh yeah, you remember your brothers and sisters, like that you walk through the fire with. Yeah, absolutely. My best friends are still the old Commodore crew. Yep.
Yeah.
And as I've said, if one called, I'd drop whatever I'm doing and get in the car. I wouldn't even need to know why. I won't tell them that, because then they'll use it to mow their lawn or something like that. So, or shovel the driveway. So, no, I'd be there for them.
So you say like the adversity sort of breeds camaraderie, and I have a fond memory of being in Ireland for sysops inside of Google, and we had somebody in our data center downstairs for the building doing something with the electricity, and that took down the entire rack of machines for that office.
Right.
The office manager went down there and then started unplugging power cables and then replugging them because he was freaking out that we were losing money because everybody was down. I was the only sysop on site, and I was struggling to bring everything back up while this guy's doing that. And I was talking with people over IRC internally to try and bring everything back up, and it was just a complete nightmare trying to do that. But the adversity made good friends. So like I knew who to talk to. I knew who to work with, and we finally got the thing up after a couple of hours, but it's just like, oh man, just the craziness that happens.
Yeah. Yeah. And I've seen that just from doing network consulting. You get the cleaning people symptom, where they go through unplugging different ones, or the popcorn syndrome, which is you pop the breaker, popping the corn in the microwave and get the wrong breakers trying to find the right one.
Yep.
Yeah. Seen it all. Yeah.
Yep.
So yeah, we opened the door and there was a kid from the Coast Guard just plugged randomly into our rack, and we had to work hard not to kill him. It was just
reasonable. I mean, that is definitely a firing offense.
Yeah.
I don't know if the office manager got told off for that, but the site sysops manager went into the room. I said, "Colm, please help me. This guy's really having trouble." And he ended up walking the guy out of the room, and I don't know what else happened after that.
Right.
But that was interesting.
Yeah. That sounds. Isn't it funny what causes some problems too? I remember an AOL outage that was caused by two teams doing maintenance at the same time without knowing it. So they sit there and now they're both trying to flip back and flip forward. They're, back out their changes. And if they hadn't, like, after 12 hours gone to the cafeteria and like, hey, us too, and figure out what's going on. Oh yeah. Well, we loved it. I owned an ISP back then. I got like a 10% bump from AOL going offline. Hey, CJ Bear Gaming, how you doing, man?
Yeah. So, yeah, lots of good memories, lots of good things, and AOL was totally nuts too. Like you look at if you get a chance, definitely take a look at the Quantum Link talk. Quantum Link Reloaded, I think, that was given at VCF Midwest. AOL was built on top of Quantum Link, and so you can imagine kind of how crazy their setup would be for essentially a national BBS in the early days. And apparently, the early versions of AOL were actually ports of Quantum Link to PC. So they were doing all kinds of insane things like per packet toll, or what's the term? They were connected over AX25 coast to coast. And so they would actually be charged per packet.
Per packet, yeah.
So like as you're moving over to PCs, you're dealing with way more data because now you're doing like graphics and like pictures and stuff like that. So you can imagine just like the insanity involved.
Right. And for a while there, us small ISPs, the big companies didn't have the advantage. If you had 100 phone lines, you needed 100 modems and a POP local to that area with 100 modems, right? So you had to buy offices, and I own like 5 or 6 offices in South Jersey, strategically placed for maximum coverage of the phone lines. And then then later you just plugged in an ISDN line, ported the entire state to it. Yeah.
Yep. And then suddenly you just reinvented the ISP. Easy peasy.
Yep.
We went from being a BBS to an actual ISP.
What's that?
I said you would go from being essentially a BBS to an actual ISP.
Yeah, yeah. And I never had a BBS, but so I started. But I remember on the ISP again running off BSDI Unix. I remember the first time 2 modems lit up, and I ran over to a terminal to see who they were and stuff. So it's like, oh, maybe this will work.
So did you run SLIP or PPP, or did you actually have people have PPP. Shell access?
Oh, I sold Shell, right?
Yeah.
And then Shell and Radius became separate things, and then I had to explain that to people that changing your Shell account just screws yourself, and send mail, all that stuff. Oh, NNTP news.
NNTP. That's news.
Oh, yeah. I was always fanning that one with a towel, trying, keep going, buddy, keep going. Because it's like
NNTP was nuts.
It was, and I think I dedicated like 330 kilobits a second to just the NNTP feed.
Yeah, I believe it. I mean, I was looking into trying to run one back in the day, and just a copy of NNTPD, and like the instructions for setting it up was like, make sure you dedicate an entire partition to NNTP. Not even a file system on it, just a partition of space.
Right.
Because apparently they had like crazy ways of optimizing how it indexed things and stuff like that. It was totally nuts. Still going strong today, but it's not like what it was.
It's not like 20 years ago. We had NNTP and we were lucky to have it. Oh, what was CD-ROM.com? Do you remember that? There was a depository that was...
Yeah, that was Simtel. Yeah, so I never actually got any of their CD-ROMs. I actually had... it was like back in the 90s. Good grief. Yeah. But they were like the clearinghouse for PC software. And so they used to have like a way of shipping out CDs to you of like just gobs of their data. But then they ended up putting it up all online. And they had gigabytes of software, gigabytes in 90s.
Right.
Walnut Creek, not Simtel. Yes, you are absolutely right. Walnut Creek. That's the name. Yeah.
And they ran on FreeBSD, if I remember.
They did.
Somebody just said FreeBSD.
Well, I mean, honestly, I honestly think FreeBSD probably would have taken off a little better if
Oh,
there
it
hadn't
was
been that
fine.
freaking
Yeah.
that stupid
The
lawsuit. Really killed it.
Yeah, I use BSDI, but NACnet, Net Access, north of me, he used FreeBSD, and
Cool.
we had the same kinds of problems. It doesn't matter; you're always going to have one.
So recently, the NetBSD
Yeah.
software archive went down, like recently.
Oh,
So I've been spending a lot of time trying to mirror it. So BitSavers actually did the initial mirror of his copy, and then I started
okay,
mirroring using rsync over to my server. And I'm
okay.
hoping, fingers crossed, that we can get a torrent up to get that stuff more distributed. Right now, there is literally just the main distribution site from NetBSD themselves.
Right.
I don't know why there's a big thumb thing. That was really weird. Is that
Yeah.
something you did?
No, not me. I think somebody liked us or something. Maybe I don't know.
Huh. Weird. Well,
It's the machine talking to us.
I don't know
It's
why
the
that happened. That
June
was really
bot in the
bizarre.
machine.
So we didn't have access to the EU mirror because we didn't know about it. And so everybody in the classic computer Discord were kind of down because NetBSD is one of those versions of BSD that has all kinds of versions for like crazy weird hardware, like what we have in our collections, most of us.
Oh, okay.
So like when that mirror went down, suddenly you couldn't run your VAX. So I said on the YouTube streamers panel, there's no legal way to run VMS. Well, the
Oh,
alternative is to
yeah.
run NetBSD.
And you got a
But if
good
the BSD
applause
mirror
off
is
that.
down,
Yeah.
you're toast. So, yeah, mirror
Yeah.
that stuff, man. You gotta get it up.
Break the law.
Major Tomo.
But
Oh no.
But you made the point that every single machine would not work if they followed if people weren't copying the stuff against the rules of DEC.
Okay, so
But
this
BitSavers.
is true. There is a hobby license for OpenVMS. However, OpenVMS that exists today is built by I believe it's a company called VSI. And they have servers that are built around, if I recall correctly, I may be wrong about this, Itanium hardware that they still deploy and service. And so the hobby license is specific to that version of OpenVMS. You cannot use the same license for original DEC hardware. Unfortunately, HP shut down that hobbyist license, and all of the licenses have expired at this point. So that this is unfortunate, but there is no legal way to run VMS on actual DEC hardware.
Wow. You imagine years from now, cars will go through the same thing. The software will be invalid in your car, and it would run if the electronics, if the DRM wasn't, screwing it or something.
Well, that's actually a real thing. So I have a RAM 1500 from 2022, I believe.
Okay.
And here we go again. The big thumbs up. Very strange.
Nice.
Anyway, that machine has essentially a web services thing that will give me the ability to remote control or remote start my car. But unfortunately, that's a pay for subscription service.
Right.
So, like, that's kind of the direction that cars are going.
Just evil. Your car
it really
is here.
is.
You are here, and they're paying for a server here as a monthly to not. But it's here. You could yell at your car. It's that close.
Yeah. Yeah. Well, that's actually why.
Evil.
That's why this is so important, right? Because this lets you do things like run AI locally on this device physically. Like you can actually grab it and it's actually got the AI on it. And so like we need more projects like this. We need less cloud things. We need more hard physical things that we get in our hands like this. And I just don't know how to get people to build more physical artifacts like this. Maybe I should just like buy a bunch of dev boards and throw it at people.
Make 3D printers work better.
Yeah. So follow on to that story is kind of interesting. So
Okay.
you can see how fine this print is. It looks really, really nice, actually. Matthew did an amazing job running the printer. You can see this was done with a 0.4 millimeter nozzle using a Prusa i3 Mark III's, if I remember correctly. Matthew will probably correct me if I'm wrong. I hope. But yeah, like it looks pretty nice, right? Like it actually looks almost like injection molded plastic, aside from the ribbon on the side. And that's pretty cool. Like the Mark IV is a really good printer. And I'm kind of following up that with this. So this came out of my Prusa XL, which we talked about in the last stream. You can see it's actually decent. I mean, this was a draft print that I did.
Right.
But the thing I didn't realize was that the Prusa XL uses a 0.6 millimeter nozzle. And so the end result is that you can see a lot more imperfections, a lot more obviously.
Right. Right.
But the advantage of this thing is that it doesn't bleed color. So this was actually a multi-material print. I used 2 different PETG filaments, which is probably half the problem. But this guy doesn't have any like green bleeding into the gray. And so if I switch over to another print that I did, a multi-material print on my Mark III S, you see I've got white here, right?
Right.
Let me see if I can get this a little better on the camera. Oh, why is that not working? Okay. Well, we'll just have to manually do it. So like I've got the red there, and it looks pretty good, right? Red and white, you know, the striations are pretty decent.
Right.
But then if we rotate this way, you can see there's a big red streak. And it's a little hard, a little bit faint, but in person it's a lot more obvious. But that red stripe right there, that's what happens when you have a mixing nozzle. And on my i3, I've got the MMU2S, and it just uses the same nozzle to put out the plastic. And so when it did that red piece, it then still had some red in the white, and so it just turned into a mess like that. Whereas this guy doesn't have that problem.
Right.
It's a nice, clean line. And even down in here, it's very, very similar. You know, very clear, distinct separation between the 2 colors with no bleed. So, yeah.
Very cool.
Yeah, it worked out pretty good.
We should find a way to light that.
But
like your radioactive green, so it just glows at night type thing.
You know, a little thing like this is kind of nice, right? Like, it's pretty cool. But this is a Prusa XL. This thing is as big as my palm. So I went and gave it a torture test.
Right.
This is gigantic.
That's cool. Yeah.
So this is a giant Gridfinity case that I printed up over the course of 2 days. And you can see with a 0.6 millimeter nozzle, you don't really care too much because you're printing massive things. And the end result is that you have a really nice, giant, usable thing like this tool case that I can use for anything I want, basically.
Now, did you get this out of a library of a system for like the different holders and the thing you just showed that went in there, the tray?
Yes. So Prusa actually runs a site called printables.com.
Okay.
And it's kind of a competitor to like Thingiverse or Thingies.
Yeah, I've used Thingiverse.
Yeah. Yeah. And the difference is that these prints are supposed to be verified. So like every time you upload a model, you also upload the G-code that goes with it and you verify the print. So these will always, or at least the theory is that they will always print. And you don't have bad models or anything, or slicing errors or anything like that.
Or infinity or...
or infinity, or like, I don't know, golden spirals or fractals, which,
Singularities.
if you're in the 90s and you have a lovely wish to tick off your local computer sysadmin, you print a postscript fractal on your postscript printer and watch as it sits there and computes all day.
Right. Right.
So
Right.
yeah, I mean the Excel is actually turning out pretty good. It's got some issues. I mean, it's not all roses. So like if I zoom in on some of these buckles, you can see one of the problems that I keep running into.
Okay.
And that is that it doesn't print PETG very well right now. This should be a much more defined shape in here, but you can see it's sort of look like all these little filaments in there. And maybe if I can zoom in a little closer. That's because it's not, it oozes a lot. And part of this is because the filament I was using was a bit
I
wet.
was going to ask if it's because it doesn't cut it off sharply.
Well, so they have a solution for that.
Yeah.
So if you go slow with plastic, it will just stretch out into a giant filament. If you go fast with it,
It'll
it breaks.
Right.
And so the idea is that when you're printing this stuff, you should retract the filament out of the nozzle and then move the nozzle away really quick. And that should, in theory, break it. But it takes a lot of tuning to get it right. And so right now you end up with this kind of a mess. It still works.
You overwhelm the modulus of elasticity is when it breaks?
Yes. Something like that. I don't know. I am not a mechanical engineer or a materials engineer even. I am just a lowly software engineer.
Well,
I work on operating systems.
I suck at mechanicals, but I remember some of the things the MEs would beat me over the head with. So yeah, I can't count the number of times I've had to say, did I not tell you I suck at mechanicals? Why are we have? Of course it's wrong. You asked me to do it. It's, it's nothing hard. I mean, it's adding together tolerance. I do that all the time in timing. I had timing tolerances. How come I can't add, lateral law? Yeah. Wow. And me reading a tape measure is a joke. I don't know what I do wrong, but it's like I'm like 12, 13, 43, and I'm counting the wrong numbers. What's that?
Tape measure?
Oh, yeah. You got to have them everywhere if they're going to be. Oh, yeah. I have, Kapton tape dispenser.
Okay, now that's just, why? Why do you have that wide of Kapton tape? What's the point? My Kapton tape's like this wide.
Right. So let's see what else silly is laying around here.
I did get something new today. So you were asking me the other day about a Kim 1. And this came in the mail today. And this is kind of an interesting one. This is a Kim Uno. It is a Kim 1 replica on a little tiny square board like this, with two LEDs, 7-segment LEDs, I should say, and uses an Arduino Uno to actually drive this whole thing and emulate a Kim 1.
Wow.
So yeah, these kits are being made as a replica because you can't get Kim 1s anymore.
Yeah, I just gave my Kim 1 to somebody and they don't know it yet. So there's a box heading to somebody out there. Wow, that's cool.
Yeah.
So and so everybody knows Kim 1 was not designed by Chuck Peddle. That went around for a while, but it was a guy named John May in the calculator group. And Peddle will even say, look at it. It looks like a calculator. That should tell you where it came from. And he's absolutely right.
Interesting. That's actually a part of Commodore I never think about.
What's that?
I just the calculator group. I never think about that.
Same here. Yeah. It was before my time, and it's kind of like, but when you hear Leonard Trammell talk about that era, where he's talking about the technology and how they've stressed it and did it and had a bug. And yeah, it's amazing. It's like a 4-bit version, a nibble of what, you know, I got to use bytes at least.
Nibble.
Yeah, that's
Bytes.
the. Are you trying to do your
No,
logo?
I'm just being silly.
Nibble. Oh yeah. I remember having to correct the spelling of you're spelling of nibbles at the various VCFs we've been to. It's
Yeah, people keep using eyes and then ampersands, and it's like, that's not the logo.
No,
But that's okay. It doesn't have to be perfect.
I've already forgotten what you said arrived today. What arrived today?
Oh yeah. So I've got all these vintage machines behind me. And these stupid things, they use 1970s proms. And a lot of these proms have not been backed up or recorded anywhere. So you'd think, all right, well, let's just go and grab your typical TL8266 or whatever the model number is, TL8662 plus double EEPROM reader, right? Well, unfortunately, this is still too new. These machines behind me, they don't just use 5 volts. They don't just use 12 volts.
Or more.
They use 5 volts, negative 5 volts,
5 volts,
and 12 volts.
12 volts. Right.
So trying to read one of those with this guy, which only gives you a 5 volt rail, is basically a non-starter. So I started looking around, and well, this thing came today, and it's heavy.
Yeah, I was going to say that's the June heavy noise.
Yeah, this is the June heavy noise. It's about as heavy as some of that equipment behind me. Yeah. So this is a data I/O.
Yeah.
Now, these things are really hard to find these days, and they're freaking gargantuan. But this is what's called a data I/O Series 20, I think, if I remember correctly. And then bringing this off, you can see the gloriousness that is a Prom programmer from the 70s.
The gloriousness.
And I do mean gloriousness. These things are awesome.
All hail the data I/O.
Yes. So yeah, even though it has a keypad, you would never actually ever use. Well, I mean, okay,
well,
you would use this keypad, but you wouldn't use it for like doing a whole lot of programming.
There's a story in my book about standing at that keypad typing stuff in.
I believe it.
But it was an unusual circumstance. And I made sure there was an audience so that the word would spread I had done that, you know. So I had a little PR going, you know.
These things are super obtuse. You'll notice it's got this black spot up here. There's no display.
Right. It's just style.
Yeah. So you just have to tell what it's doing by these LEDs. And using this interface is not exactly the most intuitive thing. It's actually quite confusing. So the fact that Bill was able to get it to work at all is actually quite remarkable.
Yeah. No, I remember being able to go to whatever address, whatever memory, change it, you know, insert.
I may end up picking your brain on that later. But the cool thing about these guys is not that it has the crazy voltage things, but like, you see this? It's not like the TL866 where you just have one thing. Like you've got this connector for 24 pin and 28 pin proms.
Right.
Then you have this one for 40 pins. And then you just pull this out and you replace it with something like this.
Right.
And now you can do a totally different family.
Yeah. And the bigger units had just insane modules they could put there. And they could program like military encrypted PLDs and stuff where the PLDs in the module are themselves encrypted.
Yep, exactly. Crazy stuff. And
yeah,
this being a Prom programmer, it will also do EEPROMs, UV erasable ones, and it even comes with its own little UV eraser.
Little eraser.
And you're supposed to actually put the chip up into this little chunk of foam. It's kind of hard to see.
Okay. I got it.
But yeah, there's a chunk of foam here, and then you put it down. but I do find it amusing. The bulb down here has a really amusing piece of text on it.
All right.
And that is, yeah, there it is. So get a little closer. It says, never look into the burning. The burning.
My eyes.
Never look into the burning. So, yeah, that's going to be kind of the new watchwords, I think.
It burns if you don't look into it. I mean, come on.
So that was my find, and it arrived finally.
Cool.
So now I can actually get those stupid EPROMs imaged. But there's one other side problem with this thing. It really, really needs to run plugged into a DOS machine. It will not work with anything else but a DOS machine. So I have to put together a PC that runs DOS with their software on it and everything, and it is notoriously finicky.
I'm sitting here thinking if you need a PC, or can you dump it into some virtualized environment on an Arduino?
Yeah, I would love to do that.
But yeah, but
the UI is on the PC. Those buttons are not a UI, right? So.
Right. So here's my little EPROM eraser that I got off probably eBay years ago.
Yeah.
No warnings about not looking into the burning, though. Oh, well, I should get Google Translate out to see what that says, in case it might say that, actually.
Do not look into UV light with remaining eye.
If you can read this, you're blind. Just not yet.
Something like that.
That's like the people go mountaineering, right? Take their goggles off, put the goggles on, and it's like, you don't know, but you're already blind. You'll just takes 4 hours.
Yep. Well, that's. Right. I think that's all I had on this side.
No, you got something else.
I do.
You got 2 of them, actually.
Two of them.
Pie of the Month Club.
Oh no, I didn't bring those in here. And I'm not going to go run them, but
no, yeah. They're only Pi 400. You just go look one up on the internet.
Yeah,
no,
exactly.
I sent one to June as a joke, and they sent me 2, so I had to buy her another one, and she gets 2, and it's like.
So I have 3 Pi 400s. One of them is 2 of them are Japanese, courtesy of Bill. So yeah.
I figured you already had one, but I was going to be like,
I told you I had one.
I don't
but these are Japanese.
Stuff.
I don't have one Japanese.
I have Bill Herd disease. We've talked about that, I think. Maybe I imagined that.
Maybe you did. Maybe you didn't. I don't know.
Let's see. Usually I just look for puddles of drool. And then I know, I've had a blackout. So, I suddenly come to and big puddle. It's how long was I out? Even the cats are laughing at me.
I believe it.
So I can't wait for another VCF in 10 months.
Yeah. That's a long time coming. But in the meantime, we have Quartz Fest. Yeah. So Quartz Fest is actually a ham radio thing out in Quartzsite, Arizona. And we're going to plan on going out there to hang out and do some ham radio stuff, maybe do some electronic stuff, and just have some fun in the cold desert.
Would they have like sample ham tests just to see like how well you would do if you were to test?
Honestly, I would expect them to have testing at the site, to be frank.
That's
it's an organized thing.
My real question, would it be?
Hams are known for that. Like anywhere we gather, we tend to have testing. So
okay.
Between ham fests and non.
Since we don't need to know Morse code, and
that's right. You don't need to know it anymore.
Right, and if I could learn probably the laws, I assume the rest is electronics mostly.
Yeah, it's mostly electronics, like how does your antenna work? How does transmission theory work? Like what frequencies can you transmit on?
Right.
Yeah,
and what I don't know is the KU band is between, I've forgotten all my bands,
Well, you won't be tested on that. You'll be tested on things like the band plans. So like 20 meters, 18 meters, 5 meters, those kinds of things. And that's all about how long your wavelength is on your antenna.
Right. Or
So
so calculating quarter wavelength and stuff like that.
yeah. Yeah.
All right.
So yeah, you won't go up into KU or anything like that unless you're doing something crazy.
Well,
Which,
yeah,
your bill,
yeah, sure. Well,
I would expect you to do something crazy.
So, yeah, when I took my TV repairman's test to be a TV repairman in New Jersey or in Indiana, you had to test, and I had to be able to generate like what's the sound carrier for channel 8. You know, and it's like, okay, take channel 6 at 54 and add 6 meg per channel. Yeah. About Colonel
So here's an
Hardwick.
interesting question. Yeah, so the lieutenant colonel, honestly, I have been looking for one for a very long time. But I have never actually used one. Have you ever used one?
Used what? A lieutenant?
A lieutenant colonel?
No.
So it's a CMD, not a CBM, a CMD
Which
peripheral.
came after my time. Yeah.
Yeah, it was a weird one.
I was going to say that was my trauma and medical phase. Was when CMD was out, I was off doing something else.
CBM was out.
What's that?
Commodore Business Machines, CBM.
Yeah, well, they were gone or on their way out. And then, it was CMD you were talking about, right?
Yeah, it was a different company.
Right. Did I say CBM?
You said CMD.
I thought you said CMD.
Okay, we're both confused now. We both have.
All right. So the question is, if you're running Hamming code, is there enough error correction information to recover the conversation?
What's a Hamming code?
Isn't that the early error correction things from hard drives?
Yeah, I think that's actually
Fire
like really
codes and
early stuff.
Hamming? Yeah.
I'd have to go watch
some kind of math,
I'd have to go watch Ben Eater again because I think he's got a thing on error correction and how it works. And I don't know if he covered Hamming codes or not, but definitely shout out to Ben Eater because like he's taught me a few things that I didn't know. Worth a watch.
When I
he covers parity at least
things like Hamming codes, I think of exclusive OR gates and latches.
Mm-hmm.
And the juju is how those are wired, basically.
Yep.
Yeah. And you could design it to not be externally readable by the logic analyzer you were talking about.
Huh.
The stimulus thing, I'll bet if you designed it right, you can't get to the internal state. I'll talk to you offline
actually. Yeah. We should.
Yeah. Because it's like, we're so involved with design for testability. I haven't designed for not testable,
Yep.
And that's, so there's a whole conversation to be had about how do you protect your IP if you're building overseas?
Yeah, that's actually a real big question. That's actually something we're trying to answer on my team right now. Okay, not my team, a parallel team that we are using the artifacts from.
Okay.
So, yeah, there is some existential questions there because, like, once you've got your silicon, and then you send it over to an overseas foundry,
it can be read. Yeah.
It can be modified without your knowledge. So how do you protect against that? So it's a real and present problem. This is actually very similar to the super micro problem because it's the same level of nefariousness, if you will.
Mm-hmm.
Like the super micro problem was Supermicro is a manufacturer of PC servers, modern servers. Right.
I loved them. Used them for years.
Yeah, but they're a Chinese manufacturer, and they have been caught adding components to their boards that shouldn't be there.
That's right. They're like, what is the sniffer thing
Yeah,
on one of the external connectors or something?
right. So like it was just something that looked like a passive, but it was doing a lot more than just passive work.
Right.
And so that was kind of like big alarm bells. Now people are thinking, all right, well, we just found out that motherboards are being tinkered with that way.
Right.
What are they doing to the silicon that we're sending over there? We can't
Right.
even inspect that.
Right. Right. Not
So,
without doing deep forensics and stuff.
right. So like you can get into doing all kinds of crazy things like you can the what's the term? You're dealing with electrons, so there are certain properties about electrons that you can bank on as means to detect modified silicon. So, like, if your software detects a certain amount of voltage in a certain area, then you can know it's been modified. You can do certain other checks to make sure that your silicon is safe. And then you get into doing like crazy things like public key cryptography chains to verify like all the parts all the way down to the end.
Right. Right. And I'm
It
sitting
gets
there thinking
really
about
wild.
the first thing you said, where I'm visualizing a heat map out of the EMs, out of the electron density of the silicon changes you were talking about,
Yeah.
differentiated against the sample or something.
Although when you start getting to some of the modern node processes, it gets a lot harder to see that.
Oh my God. No,
Like you talking 7 nanometer, you're done. You can't
those
do it.
things don't even work. It's all a rumor. What?
Hey, that you're not wrong. Like in terms of silicon stuff, like now you're starting to talk about like we're on the edge of understanding how some of this technology works in some cases. Like
Yeah.
when we were working on Coral,
Right.
we had some DDR RAM on the SOM, right?
Okay.
And DDR RAM is like one of those weird chips. Like it has its own protocol for communicating to the chips. And
Right.
it's a lot more complicated than say just a DRAM style refresh, RAS and CAS, right? This is some kind of like crazy thing that technically shouldn't work, but does. And it's getting to the point now where when you have DDR on your machine, you have to have the manufacturer of the RAM run a generative program that tests your RAM and your DDR controller at the same time to generate a program to teach the controller how to train itself, how to talk to these DDR chips. So it's like generating results.
Right.
And
And if there's an error in that process, the result is a few hundred picoseconds of skew or something.
right, or you just end up with chips that just stop working. You end up with random weird failures in your RAM because all of a sudden you're dropping bits on the floor and you don't even know it. So we had four different, well, we had some number of, I can't remember the exact number. We had some number of different providers for the chips on these things. And we had a room filled with these just running memory tests because at one point we could not get the DDR to sync up.
Yeah. Yeah. And I remember the juju that went into some of the DRAM testing in the 80s, where they looked at the actual physical layout, and the layout's not linear, so it'd be like cells 1, 5, 7, 13 or something around a bit. And knowing that, they would drive all these bits high and see what happened physically to the bit in the middle, right? And it'd get drug along or it'd stay fine or something. And so I remember the software guys talking with DRAM designers to say, how can I break your part? And that's cool.
Cool.
Yeah. And I, out of habit, like when we were doing the 128, I was all the time adjusting that power supply down to 4.75 and up to 525. I wanted to make sure I wasn't accidentally testing something that won't work in production because I'm using the same power supply all the time.
Yep. For us, it wasn't voltage. It was actually heat. So we had some of these in a chamber that we would adjust the temperature on to see what would happen to the DRAM training. Not DRAM, but DDR training based upon the differences in temperature, because the distance and the way this chip is manufactured, like you have to deal with the temperature variations. Like it's nuts. Your voltage is almost always stable because you got a PMIC in there, but
Right.
temperature is enough to throw it off.
And you try and lay out on isothermal lines and stuff, and but it's still it doesn't work. It's rumor. I say the same thing about floppy drives. I've seen the video signal coming off that head. There's nothing there.
That's right. It is a video signal. It totally is.
It's noise.
Yeah.
It's entropy. It's
So the funny story, actually, I was trying to troubleshoot one of my 1571s back over there, and there we go again. There's the mystical thumb. Let's try that again.
Who's doing the thumbs?
There we go. Okay, so it's like some mystical AI somewhere in StreamYard that is doing that.
Oh, that.
And I don't know why. That is really bizarre.
I feel violated.
Oh, wow. Does it do it on this side?
They're watching my motions to...
Yep, there it goes. Okay, one more time.
I can't do it. Oh, because it doesn't recognize that as a hand. What'd you do?
I did this. Okay.
You know what? I wonder if yours is enabled and mine isn't.
You know, I actually think that probably is an Apple thing. Now that I think about it. Because this is running through Apple's firmware. So who knows? But with
Apple's
that,
evil. Right?
We are now up to an hour and 11 minutes. I think we are actually at time.
Yeah. You ready to go to bed?
I think it's time. I just got back from SamSat, so naturally I'm very tired. Didn't get a lot done, but hopefully next weekend we'll have something interesting for everybody on the stream right now. Stay tuned.
She likes to do that. I don't want to do people. And when she says one thing, she means three things.
Maybe. We'll see. It depends on how things are going to work out. But yeah, it could be very, very interesting if people are interested in vintage computers and getting stuff up and running. SamSat is actually a very awesome place to volunteer at. I strongly recommend it.
Maybe you could even stream from there someday or something.
Dang nabbit, you let the secret out.
You didn't have to agree.
Dang nabbit, I made the secret.
You could have said,
okay, quick,
that's
we'll
impossible.
Just do this. Yeah, there we go. Okay, now I'm not here.
No, you just, all she had to do was, well, that's unlikely. Except, you know, us people that aren't used to not tell them the truth is, will that be unlikely?
Anywho, thanks folks for joining. It was a pleasure
everybody.
Again.
Yep. And we'll see you maybe next week. Let's keep doing this.
Yeah, absolutely. See ya.